In computing, a nibble is a 4-bit aggregation, or half an octet. It is also known as half-byte or tetrade. In a networking or telecommunication context, the nibble is often called a semi-octet, quadbit, or quartet. A nibble has 16 possible values. A nibble can be represented by a single hexadecimal digit and called a hex digit. A full byte is represented by 2 hexadecimal digits. Therefore, it is common to display a byte of information as 2 nibbles. Sometimes the set of all 256 byte values is represented as a table 16A, 16, which gives easily readable hexadecimal codes for each value. 4-bit computer architectures use groups of 4 bits as their fundamental unit. Such architectures were used in early microprocessors and pocket calculators and continue to be used in some microcontrollers. History: the term nibble originates from its representing half a byte, with byte a homophone of the English word byte. In 2014, David B. Benson, a professor emeritus at Washington State University, remembered that he playfully used the term nibble as half a byte, and unit of storage required to hold a binary-coded decimal digit around 1958, when talking to a programmer of Los Alamos Scientific Laboratory. The alternative spelling nibble reflects the spelling of byte, as noted in editorials of kilobaud and byte in the early 1980s. Another early recorded use of the term nibble was in 1977 within the consumer banking technology group at Citibank. It created a pre-ISO 8583 standard for transactional messages between cash machines and Citibank's data centers that used the basic informational unit nibble. The nibble is used to describe the amount of memory used to store a digit of a number stored in packed decimal format within an IBM mainframe. This technique is used to make computations faster and debugging easier. An 8-bit byte is split in half and each nibble is used to store one decimal digit. The last nibble of the variable is reserved for the sign. Thus a variable which can store up to 9 digits would be packed into 5 bytes. Ease of debugging resulted from the numbers being readable in a hex dump where 2 hex numbers are used to represent the value of a byte, as 16A, 16 equals 28. For example, a 5-byte BCD value of 31415926.5C represents a decimal value of plus 314,159,265. Historically, there are cases where nibble was used for a group of bits fewer than 8 but not necessarily 4. In the Apple II microcomputer line, much of the disk drive control was implemented in software. Writing data to a disk was done by converting 256-byte pages into sets of 5-bit nibbles, and loading disk data required the reverse. Note that the term byte once had this ambiguity and meant a set of bits but not necessarily 8, hence the distinction of bytes and octets. Today, the terms byte and nibble almost always refer to 8-bit and 4-bit collections respectively and are very rarely used to express any other sizes. The term semi-nibble is used to refer to a 2-bit collection or half a nibble but rarely so. Table of nibbles, the 16 nibbles and their equivalents in other numeral systems. Low and high nibbles, the terms low nibble and high nibble are used to denote the nibbles containing, respectively, the less significant bits and the more significant bits within a byte. In graphical representations of bits within a byte, the leftmost bit could represent the most significant bit, corresponding to ordinary decimal notation in which the digit at the left of a number is the most significant. In such illustrations, the 4 bits on the left end of the byte form the high nibble, and the remaining 4 bits form the low nibble. Examples: binary to hexadecimal. Extracting a nibble from a byte, in the C programming language, where B must be a variable or constant of an integral data type, and only the least significant byte of B is used. For example, HI nibble, 0xab, 0xa and LO nibble, 0xab, 0xb. In Common Lisp. See also, Binary Numeral System, Word. References. External links, Computer Math Forum, Apple Assembly Line, May 1981, Volume 1, Number 8.